welcome to um, Leetcode 1760 minimum limit of balls in a bag, right? Um, this question has been a pain in the butt for me personally. We're gonna go into why. I've spent most of the time not actually solving it, but reading the description and hints, reading the discussion section and hints. I love the discussion. I love the discussion section, by the way. And I actually didn't solve it. I couldn't really reach the algorithm required due to some math issues I had. And this is the editorial answer. We're just going to be going through it. Okay, let's read the question and see what's up. You're given an integer array nums where every ith bag contains nums of i's balls. So these are all bags and they have balls. This is the ball count. You're also given integer max operations. You can perform the following at most max operation times. So every operation consists of taking a bag, dividing it into two new bags, with I can't speak today, with a positive number of balls. For example, a bag of 5 balls can become two new bags, two whatever, 1 or 4, 2 and 3, whatever. Your penalty is the maximum number of balls in the bag after these operations. So literally the maximum number in the array is the answer. You want to minimize it. You want to make it as small as possible. So return the minimum possible penalty after performing the operations, right? I'm going to make this quick. At first, my intuition led me to use a heap, especially because it has the heap tag on it, but I didn't even notice. But using a heap, I thought, we have this array, let's have a max heap where every time we pop from the heap, we're going to divide the number evenly, or if it's odd, like it's even and odd plus 1. If it's even, like divide them even, and then one is just one greater than the other. Like a 9 is a 5 and a 4, and an 8 is a 4 and a 4. And then just keep inserting until we reach the base case, which the operations finish, and then return the maximum of the array, right? That's what I thought first, until this example ruined it for me, because look at the 9. My algorithm would have done 5 and 4, but here he chose 6 and 3, which actually led me thinking there's no possible way I'm going to know what division you want. How am I supposed to know how you want to divide it? So it didn't work for me, right? Then I actually was stuck, and I started looking at the discussion as I saw the word binary search, and I knew I'm never solving it because I didn't understand it. I know there's similar questions, but the thing that throws me off is the math behind the binary search. Like, okay, so the binary search consists of what? You work with the answers, so you have like an array of answers, right? And then you work backwards. So you try to fit the answer on the array, right? Instead of looking for the answer, which was the heap. Essentially, the thing is, if the answer is always going to be between 1 and the maximum number here. It's never going to be more, because you need to minimize the penalty, which is the maximum number of balls in a bag. So it's never going to exceed the maximum number in nums anyways. So that's what this starts off as. It starts off with left and right, and it just chooses a number in the middle, right? This potentially could be the answer, right? But what it does is it calls this self is possible, right? And it sends the middle in it, and the array and the maximum operations, like the arguments. And then if it works, if this could potentially be the answer, it asks like, how about, okay, let's go less, let's try less, right? Otherwise, go up because it doesn't work, and then you just return the answer at the end. So the main thing that actually threw me off binary search is this method, because the math behind understanding how it happens is not intuitive at all, in my opinion. I'm bad with math. If you're good in math, maybe you would understand it, but I actually asked ChatGPT to make it simpler for me so I could understand it, and I actually am going to show you. So anyways, let's see what happens here. The main idea here is, when you choose a middle number, you want to know, is it possible with the number of operations I have to make this number the maximum balls in the bag, right? Is it possible or not? Is that even doable or not? So the idea here is, it goes through every number in the array, and then it tries to calculate the number of operations required for this number to be less than the maximum balls required in a bag, right? And it's this calculation that threw me off, because it is not intuitive in my opinion. If you get this first time, you're a genius. Um, what does this mean, right? It took me some understanding. So we want to know from the number in the current number in the array, how do I like how many operations do I need to split this to potentially have bags that are all less than max balls in bag? Here comes this, right? So here, what I did is it says why is it so the calculation essentially is the division over 1. It told me up here it needs where are we, to calculate how many operations needed to reduce a bag, so that this is the calculation, right? Number over max balls in bag minus 1, because it says why each operation splits the ball into smaller bags, right? So you calculate how many chunks of size max balls in bags you need. So you need to calculate the chunks, like how many chunks. My brain was stuck through the process of dividing. That's why I didn't look at it from this perspective, right? But I needed to know again why the minus 1, right? It says here because, where is it? Yeah, because each operation creates an additional bag. So let's say we have two numbers, 100 and 120. We need to make the max balls in the bag 20, right? So all 100 balls are in one bag, and then we split one time. So what's happening? Two 250s, for example, or whatever. It needs 5 chunks. It would need 5 chunks to have them all 20, right? It would need 5 chunks, but that's not the number of operations. The number of operations is minus 1, because one operation creates 2 bags, and to have 5, you're gonna need. So first operation splits into 2 bags, right? Second operation splits 1 into 2 bags again, so that's another operation. The third operation splits the 60 into 2 bags again, and then the fourth operation splits the 40 into 2 bags, right? So that means you have them all 20s. So you got the 2080, and then you got the 80 60/20, and then you get this again, 40/20 for the 60, and then 20/20 for the 40. So that's 4 operations, 5 chunks. That's the confusing part in this question, in my opinion. So once you know the operations, right, you're just gonna sum them for all of the array, and if you find out that it exceeds the maximum operations, we're returning false, because it's not possible. Otherwise, we just return true. So that makes this binary search part easy, but it's just this math part that threw me off, right? So yeah, that's been it for this one. See you in the next. Thank you.